Hi all, welcome to lesson 7. Please print this lesson. If you do not have access to the printer, please copy this on a separate sheet of paper and put it in a safe folder. You should have all your lessons together so you can review them at a later time. I already have the formulas filled out using my reference sheet, which is again with the lesson. You can print it from the Canvas website. You should send me the last page, that's the independent practice, upload it onto the Canvas website, and you should do it on your own, try it on your own, and send it to me so that I know you understand this lesson. If you have any questions, please feel free to email me. Okay, some of my formulas are already filled out. So let's get started with lesson. Lesson 7, similar solids. What does similarity means to you? Right? We've done similar triangles in the past. Similarity means that if you have two shapes that are similar, means their angles are congruent and their sides are proportional. Okay? So you need to, that sides are proportional. What will that help you with? If you are given two similar shapes, if one of the side is missing, you can set up a proportion and find it. Okay, so now let's do this. The first one, do now calculate the volume of the triangular prism. So I already copied the formula, which is big B times H. Again, remember, big B is the area of the base. So now what you need to do is substitute the area of the base, which is a triangle. Remember, your prisms are named after their bases. So it says a triangular prism, so triangle is your base, right? So we're going to substitute in the numbers or dimensions. 1/2, the base of the triangle is 3, the height is 3, and H is what? 5, right? Put that in the calculator and you get 22.5 units cube. The only hot part here was to understanding that what the big B means. Okay, it is the area of the base. We keep saying it to you and you need to understand that very clearly. Okay, so let's start with example 1. It says, it's asking, it has a lot of parts to it. It says a pair of solids shown below are similar. Okay, so if they're similar means what? Their sides are going to be proportional. So it's asking us to do 3 things. Let's start with the first one. Determine the missing corresponding length. So whenever you want to find the missing corresponding length, right? Check out, I already highlighted the corresponding sides. What is my scale factor? It is 3. Yep. 4 times 3 is 12. 6 times 3 is 18. Or divide them. 18 divided by 6 is 18 divided by 6 is 3. 12 divided by 4 is 3, so you do get the same number. It is proportional. So the green sides, what would I do with that 3? Since this is the smaller shape, you're going to multiply. So 12 times 3 is 36. So you got the side to be 36. Use your volume formula. Oh, my volume got erased. Use your volume formula, and all you need to do is substitute in the dimensions. Your base of the small triangle was 6, the height is 4, and right, so you get 12. I want to keep the same colors so that it's easier for you to understand if anyone is getting confused. And the volume is what? Put that in the calculator, 144 units cube, right? So let's try the next one too. 1/2, my base is 18 of the triangle prism, 12, and then you have 36. Put that in the calculator and you get 3,888 units cube. Okay, so that was to calculate the volume of each solid. Now part C says determine the relationship between the volumes of the solids. So how do I determine the relationship? Okay, let's write that in your notes and this will make more sense. Remember, volume is what? Cubed. We always cube the volume, right? So what do you think we'll do to the scale factor too? Scale factor is also cubed. That's what it is. Volume is cubed. So scale factor is cubed. I'm getting used to this pen, right? Okay. What does that mean? Because writing it down is not enough. So my volume of my first solid was 144, right? My scale factor was 3. So cube the scale factor and you get the volume of that similar solid. So that's what it means. That's how you can find out. So basically you could have skipped all this work and you got that same answer, right? So that's what it means. Okay, pause the video and try number 2 on your own. You're doing the same 3 things for it and see if you can get that far. Okay, let's start with number 2. It says again, start with the scale factor. What's my scale factor? It is 10. Very good. 20 divided by 2, it is going from a smaller shape to a bigger shape. So your scale factor is going to be greater than 1. Okay, now we're going to just substitute in our find our volumes. The base of the shape, what does it look like? It's a rectangle. That's why we substitute a big B with by length times width. So my length is, oh, we didn't find the length. That says 4. Let's write that down. 4. The length is 4, right? Because the scale factor was 10. So length is 4. So my length is 4 times 2 times, and then my height is 3. So the volume is 24 units cubed, right? So now let's do the next one. Find the volume of the next shape. So volume is, what's my length? 40. This is pretty simple, right? Pretty straightforward. Just substituting in the numbers, and that's basically it. Substitute in and you get volume equals 24,000 units cubed. Okay, let's check our relationship. What did we say? The volume of the first one and cube the scale factor. And what do you get? 24,000, right? Up, bad. I don't know. There was something on the screen. Okay, so that's basically it, right? So now let's start with the next question. Again, I would say pause the video, try the question on your own. If you have not noticed by now, you should have seen that the shape is getting from bigger to smaller, right? So our scale factor should be what? Between 0 and 1. So what is my scale factor? 4 divided by 5, which is 0.8, right? So we want to find this missing side. You can either set up a proportion or just multiply it out. So this would be what? If I was to set up my proportion, x over 8, big over small, 5 over 4. Cross multiply. What do you get? 4x equals 40. X is equal to 10. So you get x equals 10. So that's what our side is, right? And now all you have to do is substitute in. Remember, the volume of a cone right from the reference sheet is 1 over 3 pi r square h. So 1 over 3. This is one thing you need to remember. It's not telling us to round to a certain number. So what happens is, do not put the pi in the calculator. Okay? H is 10. So let's write that down. Let's make a note in a different color. Do not put pi in the calc. Why? Because it is not telling us to round to a certain number. So that's what it is, right? Back to a question. So volume is, put that in the calculator, just these numbers. I'm just going to say these numbers. And it would be 250. Leave it in 250 over 3 pi. Okay, so now similarly try the next one. Volume is 1 over 3 pi. Do not put the pi in the calculator. Your radius is 4 square and the height of the cone is 8. It was very simple, right? All you have to do is know how to put what to put in. It is 128 over 3 pi. Okay, so I have a little tickle in my throat. So anyways, let's go. Let's show the relationship, which is what? 250 over 3 pi if I was to take my scale factor, which is 0.8, and cube it, and I do end up with 128. Do not put the pi in the calculator. And if you put this thing, leave the pi out. So I'm going to just circle it. Leave the pi out. If you put this whole thing into the calculator, you will get 128 over 3. If you put the pi in the calculator, you will get a different number and you'll confuse yourself. So try not to put the pi in the calculator. And how do we know that? Because it did not ask us to round to a certain number. Okay, the last page. And there is for me to do. The last page, the independent practice, is something that you have to do. This was a Regents question. Actually, it was a 4-point question on one of the Regents. A little tricky question. That's why I want you to take your time and understand the question. Try to do it on your own and then see what I have been doing. Okay, I'm going to read the question. Let's get started with that. A water glass can be modeled by a truncated right cone, a cone which is cut parallel to its base. Okay, if it's cut parallel to its base means what? That they are, if the bases are parallel, then it would be the height. We'll talk about it. The diameter of the top of the glass is 3 inches. It's talking about the diameter, but we need the radius. So what would it be? We're going to mark it up. Let's mark it up. The diameter is 3 inches. So this would be what? The diameter across is 3. So this would be what? 1.5. Yes. Right? So the radius is, let's write that down. Radius is 1.5. The diameter of the bottom of the glass is 2 inches. 2 inches. So the radius would be what? 1. So bottom of the glass. This is 1. Isn't this the same thing here? This is 1.5. This is the bottom of the glass because they took this cone and cut it, and that's what they're saying. And this is 1. Okay. So now it's asking the base with a diameter of 2 inches must be parallel to the base with a diameter of 3 inches in order to find the height of the cone. Explain why. So what do you think? If it weren't parallel, what will happen to your height? The height would be slanted, right? And heights can't be slanted. So let's write this down. Heights are, do we know what the symbol means? Perpendicular. I'm going to write it down. To the base. They're straight, right? Whenever you go to the doctors, are you at a slant when you they check you for the height? No, they tell you to stand straight, right? So that's why if the bases are not parallel, the height will be slanted. Okay, so you can pause the video anytime and do that. Okay, so now what is the second part saying? The 3 parts to it. This was actually a 4-point question, so definitely they will ask you to do a lot for that. So now it's saying determine and state in inches the height of the larger cone. When we are saying the larger cone means this big cone. What do we know about these cones? They are similar, right? So what do? We set up a proportion, right? We call this larger length, I'm gonna zoom. So I said this whole thing in blue is x, right? We knew the height of the glass was 5. If that was 5, would the remaining be x minus 5? And I drew out these 2 cones out here, the bigger one and this bottom small one in red, and I color coded it so it's easier for you to understand. Right, so let's set up proportions. So it is, I know these radii, let's write these down. This was what, 1.5, right? And this was what, 1. So now all I'm going to do is set up a proportion just like we did for the last one. So it's going to be 1.5 over x. So I'm doing the radius over the height, and I'm going to do the same thing here. Radius over the height. That's another way of setting up a proportion. There's so many ways you could have done it. You could have done 1.5 over 1, x over x minus 5. No matter which way, as long as they are done right, there's no, like, there's so many ways you can set it up. Cross multiply, right? So what do you get? X equals, okay, this is 1.5 times x minus 5. This is where people actually get confused, and now you're going to distribute it. So I'm going to try to do everything in color. So it's 1.5x minus 7.5. Isolate the x, subtract 1.5 from both sides, and you get what? Negative 0.5x equals negative 7.5, and divide negative 0.5, you get x equals 15. So what is the height? X was what? Something in blue, right? So the height of the larger cone is in inches, and it said inches, so you must write inches or you lose points. Okay, so let's write that down. The height of the larger cone is 15 inches. X is equal to 15. Okay, so now it says, the next part says what? Determine and state to the nearest tenth. Okay, the minute says nearest tenth, rounding. 10 has how many zeros? 1, so you're going to round to 1 decimal place. I want you to start putting that. We've been doing that in class, so I want you to continue doing that, right? Of a cubic inch of the volume of the water in the volume of the water glass. So I want to find the volume of this whole thing, this whole thing, this whole thing, right? So if I find the volume of this bigger cone and subtract the volume of the smaller cone, would I not be left with just the volume of the glass, right? So that's what we're gonna do. That's why I write the whole I don't want is equal to the water glass. And since there are cones, I copied the cone formulas, and all I'm gonna do is substitute in. So volume is 1 over 3 pi. My radius is what? 1.5 square, and the height is 50, right? That's the larger cone. We just found 15 from the previous. Put that in the calculator and leave it in terms of pi. Do not round it as of now. I'm going to leave it in terms of pi because I am going to round it in the end. Because if you round it here, you end up rounding it too many times, and then you make mistakes. So 1 over 3 pi 1 square times 10, which is what? 10 over 3 pi, right? Okay, what are we doing with these? We're subtracting these two. So if we subtract these two, what do we get? And now put that in the calculator. You get 24.87. You're going to round to the nearest, so it would be approximately 24.9 inches cube. So what is the volume of the water glass? 24.9 inches cube. So that's basically it, guys. Finish the last page for your homework, right? This is your independent practice. You should do it for your homework, and I will see you later. Bye bye. Have a